In this cast, we're going to be learning about how to express position and time with numbers. We need to do this in order to describe things like velocity and acceleration later on. So, in a basic sense, position describes the location of an object in some instant of time within a specified coordinate system. Okay, so what does that mean? So, well, there's three main coordinate systems that we're going to look at right now. They're all one-dimensional. The first one is the horizontal x-axis. Okay, you can remember this is left to right because horizon, that's right, the sun is over here, horizon left and right, okay? So every coordinate system requires an origin, okay? Requires a unit, so we know if it's meters or if it's kilometers. Here we have to the left, we can have, this is the west or negative direction, and on the right is the east or the positive direction. Okay, so this apple, the position of this apple could be at x is equal to plus 20 meters. Okay, this, because it's on the x-axis, this is what we called 1D notations. This is 1D notation. Okay, this is doable because we are dealing with a one-dimensional axis. Okay, so let's move on to a vertical axis now. Similarly, in a vertical, up here is the north end, which we also call positive, and down here is the south end, or what we call the negative. So we would say the fish is at y is equal to plus 40 or 40 meters south. Okay, in 1D notation, this would be y is equal to negative 40 meters. Okay, notice how we drop the south and we add a negative. Okay, because it's below, and so south and negative go hand in hand. We could also have a one-dimensional tilted axis. Okay, so if we call this the x-axis and the car is over here, we could say that the position of this car is x is equal to plus 20 meters. Okay, so moving on to time and why in our motion diagram we need to specify time. Well, here's sort of why. If you look at this example here, if we just have the frame numbers, we wouldn't know if maybe this car is just slowing down gradually or if it's a screeching halt. Okay, so we need to know what the time interval between each of these snapshots is. Otherwise, we don't know the time of this, if it's fast or if it's slow. Okay, so here what we have is we have a motion from 0 to 4 seconds, so we're kind of moving at equal speed because the distance is the same. And then over here, the distance is decreasing, so the speed is decreasing, so maybe the car is braking. Now, when we specify time, we can choose times equal to 0 wherever we like. So, we can choose this as a start, and because maybe we're interested in this when it's going constant speed, and then when it's here, this is the braking part. Okay, so, but maybe we're just interested in the braking part. Okay, so we don't have to start at 4 seconds. We can just reassign this frame at time is equal to 0 if we do not care about this part over here. Okay, so what we call as time 0 will depend on the problem that we're faced. So now we're going to be looking at changes in position through time, because that's basically what motion is you're changing position in time. Okay, a change in position is called displacement. It basically means, or it describes how far something is out of place. It is the difference between the final position and an initial position in time. Okay, and it has the symbol delta x. This little triangle here is called delta. Delta. It means change in. A Greek letter which means change in. So in this case we would say this is change in x, or delta x. And like we said, displacement, which is the symbol delta x, is final position final position minus the initial position. Okay, in math, this might be, you might remember delta x over delta y, or delta y over delta x, which is the slope. Same kind of idea here. So, oh, note here that displacement is a signed quantity. What do we mean by a signed quantity? It can be negative, it could be negative or positive. So for example, over here, if this person starts at +3 meters and then goes to -2 meters, the way we would calculate displacement was final position minus the initial position. So that's -2 minus +3 gives us a -5 meters. So that means a negative displacement means we went 5 meters to the left. If we had a +5 meters, that would mean our displacement would be to the right. Okay, so displacement is a signed quantity, which is really important. And finally, we look at change in position, and now also we can look at change in time, and that's what we have. That's what we call the time interval. Okay, the symbol again for time interval is delta t, which is t final minus t initial. Okay, so if we have assigned t0 here, and we're looking at just the time interval of the braking part, then our final time would be 7 seconds, our initial time would be 4 seconds, and so we would say the time interval of braking would be 3 seconds. And one more thing is that the time interval is always, so delta t is always positive. Okay, this is because the final time will always be greater than initial time, so you'll always get a positive value. Okay, so this is because TF is always greater than TI.